Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Okay, hello and welcome everybody in the next part of the series Docker. Um, Today we are going to discuss the Docker storage option, which is kind of very important. Nowadays, there are different tools in the market which is essentially used to manage these storage options like Kubernetes and some other DevOps tool as well. But to get the feeling that how and what it is and how that works is very important kind of so for example, let's see that what is the storage and how you can use it. So in Docker storage, actually, what happen is that Docker is designed in the way that you just create it with help of text file or Docker file, and you mention those instruction, and it create a lightweight container on top, and give you the bare minimum functionality which is needed without any extra thing. This is not window, or this is not something operating system. Yeah, well, it behave very similar to operating system, but the very nature or very basic purpose of the Docker container is to get job done, and as optimal as possible, with less storage, with less capacity, and with less usage of the resources. We have discussed the history and evolution of the Docker in the previous video, but you can refer to that one if you need to know how the technology works and what is actually underlying structure and how they are so efficient and how they make this revolution in the world of operationalizing the development. Yeah. So sometimes what happens is that you need persistency. What does it mean by persistency? That you sometimes need to store the file, or you need to get some data which is gathered on the container to the local storage, and vice versa. Sometimes on the local storage, you need to give configuration file, apps, or whatever it is. It could be anything actually to your container. You can supply that code. For example, you have an application, and in the application, actually you have some code which need to supply to each container, and you need to deploy, for example, 100 container, and you now have this file which is a specific IP address, and for example doing something, and you can supply this to all these 100 copies of container, and then it should be doing that. So that's pretty much the basic function of that. But how you do that is very important. So you do that with the help of flag v or volume. So there are fundamentally two basic ways of doing that. One basic way to do this is with help of a volume mount, which is more kind of more speedy, more efficient, recommended by Docker. Let's say like that. And second is the example is mount bind. Mount bind. So what is the mount bind? Mount bind is also doing a similar trick, but a little bit different fashion. We'll discuss the key difference between these two later on, but let's first discuss that what is the intrinsic nature of the volume. So in principle, you can get, for example, this is your container. You can get sometimes the log of the container, or sometimes you also need to provide the data to the container. But essentially, because this storage is always default, which means that you cannot give the path to it. We'll do the demonstration shortly and you will understand better, but this is the default storage, which is normally var lib docker. Like this is lib docker, and then volume, and under the volume your score data. So that's how it's by default location is that. which means that in normal settings, the main thinking behind the volume is to get data out of container to your local hard disk. Get data from the container to your local hard disk is the main use case. And sometimes you need to mount it, which means that you need some customer location. For example, my custom location is here, home user and my app data. Now, this data, for example, I need to supply to the container to work properly. And this is my custom location where I normally store my data, and now this data is being supplied to the container. So that's the other use case, which is something like that. So in general, we have two major use cases of the storage option in the Docker. Number one is the volume, and second is the example, the bind mount. So we'll see the key difference between these two. There is some fundamental difference between these two. So right. So this is very delicate difference, and nobody is gonna tell you that what is the difference. So it is very important to know that Docker storage in the case of volume is using its own directory structure, which means that the efficiency of the Docker, which relies on the file system plus the lightweight containerization plus the Docker engine containerization technology, which built on the top of host machine or virtual machine, which make it the main player of this revolution, that it is lightweight and doable within seconds. So all its benefits and advantage and blessing lies on the infrastructural innovation or these changes, how it use the underlying um, virtualization layer from the operating system and create a very similar operation to the create a very similar file system, very similar to the operating system, for example, Ubuntu or Windows, but it is agnostic or doesn't care about the hardware plus virtualization layer, and that's why it is lightweight. And the benefit of the volume is also lies between these two, which essentially means that when you are using its default option, it has optimized and created its own file system, which is also very lightweight. So this is the main and big difference between the volume and mount. And this volume is portable, which means that there is more support, more commands, easy command, because this is built for that purpose. And on the other side, the mount thingy here has a little bit different purpose when you have application data on your local storage. In this case, this is on a virtual machine and you want to supply it to your Docker somehow. And that's why your custom location is very important in this sense, and that's why you bind it or give it to the Docker. So this is the main difference, and definitely the directory structure, the portability, and the performance. These three key elements differentiate them each with each other. So yeah, that's pretty much the theory of the Docker storage with respect to the volume, and sometimes it is very important. So let's see how you do it. So to perform it, it's very simple. You go to the any machine, which is, for example, here I'm able to log in by root, which means that if I Docker PS. So some of the container are running. I ran two container, but I can remove them. And I can say this. This copy, man. Overall, I can remove this. Container is running. Google stop. And then Docker remove one. I can say docker stop. Second one, and then do that. And docker remove again. Second container. Docker ps. Nothing is running. So the command is very simple. And uck or docker run name vol container vol example. And I'm going to run this in detach mode, and port number mapping is very important. Also 1089, port number 1089 is mapped to the port 80 for the TCP traffic. And then come volume here. And for the volume, I need to first create the volume. For example, I create any volume here, and to the any volume I could attach that volume in the end which image I need. For example, engine access the volume. And now if you see here docker ps 5 seconds ago, this thing has been created. Now if I see docker volume here, and it says the docker volume list. So well, because now I give it a name, any volume, which essentially means that in the next any volume. Okay, let me pause this. As you can see that since any volume name doesn't appear here, that's why it has created a hash function with volume name. To create the volume, you need something. For example, docker volume create second volume vol. So number 2 volume, for example, I need to create that. And when I create that 2 volume, and then I can see that in docker volume list or ls here. And now you can see that this volume is here. Now if I really want to create this volume again, for example, if I say docker ps, as you can see that this container has been already created. But now if I, for example, go here and I write this name, which is Control C, Control P, and Control B. Oops. And if I delete that, and this is my volume here, and this volume has to be attached to anything, anywhere, right? This volume, the local volume, needs to attach to, for example, user share nginx html. So this is the normal path where the html things for the nginx lives. nginx. So yeah, Now I have created another volume, and now I'm going to name it X container wall experiment number 2. Okay, the port you need to change because it is pretty assign maybe 93. Okay, you need to write experiment number 3 because this name is already taken. As you have seen that even if some of the functionality of container is failed, it doesn't mean that it doesn't create the container altogether completely, because if I show you docker ps, you can see that some experiment are running. But if I go here docker ps all, and you can see there are many different docker which has been already created with the same name. But that's easy, or that's fast it is, and that's why it doesn't take the port as well. So that's actually that. And then what I want to know is that, for example, in this in this container, I want to interact with this container, and the command is very similar: docker exec docker exec it docker exec it, and then actually docker exec it, and then name of container, and then the shell command which is needed. And now the spelling of docker is not right, so something like that. And now if, for example, I'm going to cd user share nginx html, and here, for example, I create a new file, touch test file on container, and this file should be available LTR. For example, this is the file I have created here right now, and this file should be available to my local container as well, right? And this file should be available. For example, right now I'm root in the container, and let me go. This is again something else, and if I pq, here is the root, this is the root, for example, and where is my files and storage by default in case of volume, which we have discussed in the theory that it is very efficient and it is by default location. This location is cd var lib docker, and then cd volumes, and within the volume I could see that my all volume lives here. And if I want to see cd second volume, which I be recently attached to my volume, and if I go to the data here, as I can see that test file and container is available. So right now I'm logging to my virtual machine, which is local storage, which is not container, as you can see here. But for in any case, if I want to create some file here on this volume to check the vice versa, I can say touch. I can say touch, and then I can say file on virtual machine. And as you can see that we have created this file in virtual machine. If I go here, and this file should be available in container 2, file Well, this is not I again have created this. Oh, I am already out of this container, sadly. And which this container was? This container was this ID. If I want to see this file, I want to go to local touch exec it name of container and then bash and cd user share nginx html and list nls. And as you can see, the file on container is available on root machine, and file on VM should be available to here on this container too. So both way are going each other. So this is bidirectional, everything works great. And if I want to attach this volume to any container, I can just run the docker run and volume v and name of this volume, and then I can attach this to any of Docker, right? And this is the beauty of it. Right now we are again in the root, and yeah, now let's see how we can do this same concept in our second example, which is in this case this one, where you want to attach not the local storage of your Docker, but you want to attach exactly local storage to the with help of mount. So mount could also work in keyword mount, or you can also use it by volume. The question arises that how it's really differentiate between these two. If you give the full path of your computer or any path of file system, then it recognizes automatically that this is the example of mount, because the default location and name of the volume is not given. If you give the name of volume, then system automatically knows that this is the case of volume. So that's how it's differentiate. When you give the name of the volume or the path, and the command is very similar. For example, here this is root computer, and I can go to home of the root, which is pwd root. I can remove the test file from here already, and I can remove the file on container already on snap in the root. I can clear this, and for example, this is then the container, and I can pq and then docker ps. So these two containers are running. I want to create another example with help of to show you mount volume or the mount bind, how you bind the local folder of your computer to the Docker. The command is very simple. So you run docker run, name is the doc, and you contain container mount example. This is the name, the charge mode. The port is 11,000 with 480, and then instead of volume, I want to give it my root name, and dash means that I want to map it to the user path. User USO here in Nginx. Then in Nginx I have on the Nginx I have in the Nginx I have HTML folder which render the HTMLs files, and now in the end I need the image. In the next image, for example, uh, I need to here mention the volume, which is the same flag actually again, but as you can see that Docker has been created, Docker ps, and new mount experiment is running. If I want to look into this Docker, I need to copy this, and I can say Docker execute interactive Docker ID, and here I can say bash. Yeah, now I can go to cd user share, and in this user share I can come to Nginx and HTML. So I'm here, nothing is here, but you can see the snap here, which means that directory is already mapped. If here I create something with name of touch test on VM, this should be available here to test on VM. So if I create here something in the container touch touch test container, this should be available to here to test on container. So make sure that the name here, is the root at the container ID, and then name here is the root on VM, but the files are totally mapped with each other. That's how you can map this stuff, right? And yeah, that's pretty much about the Docker storage, and that's how Docker storage works, and that's how RAL. And this is a very important concept because this storage concept is ultimately used by the higher end orchestration. Orchestration is nothing but managing multiple Docker. So in the next tutorial, we are going to see that how the Docker orchestration gonna work, and how you can manage multiple Docker file with Docker Compose and Docker Swarm. Docker Compose was designed for a very minimal use case or simpler use case, but later on the complexity has been increased, and then people come up with the idea that we need a good solution, and then they introduced Docker Swarm, which is the more efficient. Thank you very much. Hit the like and subscribe button if you like this. Bye.